Hello, my AP Physics students. This is Mr. Williams, and you have found the video for your first AP Physics 1 lecture. Oh, I'm so excited, and I'm sure that you are too. I can almost feel the excitement as you sit there watching this now, like, oh, I'm about to see some advanced scientific concepts. We are going to deep dive into some crazy stuff, and this is just the beginning. This is lecture number 1 of... I don't even know how many there's going to be by the end of the year, but we are going to go into some of the basic content today and just really start to get into the actual science of AP Physics. Now, for my lecture videos, I'm going to try to keep them brief as best as I can. I'm definitely not going to lecture you for 45 minutes or an hour or anything. See, this video should be relatively short. As always, you have now the power, because this is recorded, to pause at any time, to go back, to rehear things that I'm saying. So this whole online instruction thing isn't all bad. There are some perks to it. So let's just go ahead and get started. You should have already seen my other video on class expectations. So if you did not, you can go back, see that video. But these are those expectations again. Let's talk about what physics is. Physics is the study of matter and its motion through space-time. Not space and time, but through space-time. We found quite a few years ago, a man named Einstein discovered that space and time are really one and the same. They're not as different as we think that they are. To our brains, we live in three-dimensional space, right? We can go forwards, backwards, left, right, up, down. There's 3 different dimensions to go in. But then there's this 4th dimension of time that allows for things to move from one location to another because time passes. It continues forward. So in the same way, it's not really correct to say there's 4 dimensions, but more we have 3 spatial dimensions and 1 temporal dimension. And time's very different than space because time just runs forwards, always moving ahead. But Einstein was the one who first discovered that space and time are really one and the same thing. And if you are more curious on this, I encourage you to look up some explanation videos on general relativity. Then if you're feeling really bold, go into special relativity. But for now, let's keep it to the basics. Physics focuses on the properties that matter can have, such as speed, energy, and temperature, and asks why and how matter gains such properties. So this is a very vague statement, right? We are just looking at any object. Pick anything. I could look at, right now, a water bottle sitting on my table. Why is it the temperature that it is? Why does it have the structure that it is? We could look at this on totally different levels. I can look at the atomic interactions of the plastic molecules and ask, how are they so adhered? How do they have this definite structure? And then look inside of it, of this liquid inside. Why is the water in a liquid state? Why does it flow? And then I could ask myself, is there energy in there? Like, could I take that water and do something with it? Turn it into motion or turn it into temperature for something else? Right now, the water bottle seems to be at rest, but could I make it not at rest? How could I change that speed? How could I change the energy and change the temperature? That's really physics in a nutshell. It's very, very basic science, and as I say here, it's the most fundamental science. Its main goal is to describe how the universe behaves, which is a very... its main goal. It's a very foolhardy goal. It's going to take a lot of work to get ourselves there, but we've made really good leaps just in the last 100 years or so, and I'm sure we will have more leaps to come. But for now, we're going to keep it, like I said, to the basics. Why and how matter gains such properties. Okay, let's move forward. As with all science, we use the scientific method. You know this method. You've been drilled into it probably since like 4th grade or something. Observe, infer, and hypothesize, test, conclude. We have to try to not let bias affect our scientific work. We will be doing experiments in here, and we will try to follow this method the best that we can. And really, I really want to teach you the physics method of doing science. And you'll find that it's a little bit different than your other sciences, but we will get into that when we get there. All right, one big thing is a theory versus a law. I always like to hit on this in class because it just drives me crazy that people just still don't know this and still don't understand what is this big difference. I'm sure you have heard before, people might say, oh, well, that's something that's just a theory. And that's a very annoying thing to hear as a scientist, because a theory is a very well understood thing. I'm going to link this video for you guys to watch, and you guys can watch it at your leisure. That describes to you the difference between a theory and a law. Making measurements. So this is really the physics stuff. So all scientific work, all of it, everything in science is based on observation and taking measurements and interpreting meaning from them. That is science in its most basic form. We have a term for these things that can be measured, and we call them physical quantities. I'm going to use this term a lot in class, and I just want you to remember, to think back, what is a physical quantity? It's just something that can be measured. It's exactly what it sounds like. A quantity is just a value. Physical means it relates to the world, like it's an actual thing. So something like speed is a physical quantity. You can quantify it, meaning like you were moving at 20 miles per hour. That's different than moving at 40 miles per hour. And that quantity relates to a real thing, like your speed is an actual thing that is happening. Same with temperature. You can be at 70 degrees Fahrenheit or 90 degrees Fahrenheit outside. Those numbers relate to real world quantities, and anything that can be measured is a physical quantity. Intrinsic versus extrinsic properties. So speaking about measurements are really, we're just kind of taking some matter and measuring something about it. There's all of different properties that we can measure about it. Intrinsic versus extrinsic is just coming from, is it a property of that matter itself or from the environment in which that matter is in? So mass is intrinsic because you have if I have just an apple, well, how much its stuff is in that apple is coming from like the apple itself. There's no like outside value that's defining how much stuff is in there. But weight, on the other hand, is different. And it's so common to get these two things mixed up. And for the rest of the year, there's going to be physics questions that are going to try to trip you up on this, that are mass and weight the same thing? They're not. Mass is how much stuff is inside it. Weight is the gravitational pull on mass. So how are those two things different? Well, right now the apple weighs something, but if you took that apple to the moon, is it going to weigh the same thing? Well, no, because there's less gravity on the moon. If it were in just deep space, that apple would weigh nothing, but it still has the same amount of stuff in it, no matter where you take it. So weight comes from something outside the apple. And that's why we say it's an extrinsic property. All right, and dimensions and units, this is going to be our nitty-gritty for today. The dimensions of a physical quantity refer to the type of quantity it is, regardless of the unit used to measure. So there we have three big dimensions. So 1.45 miles and 0.36 inches are the same dimensions. 47 seconds and 5 years, same dimension. And 400 tons and 35 grams are the same dimension. What are those three dimensions that I just listed there? Well, the big ones, the three main base units, the three main dimensions. So in dimensions, that would be length, time, and mass. Those are the dimensions. We can measure length, time, and mass in a bunch of different ways, as you can see just in that last slide. But then I put in there, what are our main ways of measuring these things? So length, we're going to measure in meters. Time in seconds, and mass in kilograms. These are our main base units. And what's crazy is that nearly all quantities, all these physical quantities, the different ways that we can measure objects are just combinations of these main units. Take speed, for example. Well, miles, you travel at 20 miles per hour. Well, that's just a length divided by a time. Energy is just it's a kilogram times a meter squared per second squared. Like they get more complex, but they are just combinations of these three main things. And these three things are pretty easy to measure, relatively speaking. All right, other common units. So we talked about speed. Velocity is just length over time, meters per second. Acceleration is a velocity over time. A force is mass times acceleration. Energy, force times length, and momentum is mass times velocity. And you can see all these base units right here of what they kind of come out to be when you start multiplying different things together. This is really like our first, if you don't recognize some of these terms, that's totally fine. We're going to talk about each one way more in depth when we hit different units on it. This is really our first like semester here, is these main quantities. But we are going to do a worksheet on dimensional analysis, and we are going to play around with some of these values, but I will get to that in just a moment. All right, dimensional analysis. So what is that? Equations in physics are dimensionally consistent. And this is really our first like big physics idea. Each term has to have the same dimension. So what do we mean by that? Well, I mean, like if you have an equation that says to add things together, well, to add them, they have to be the same. Like if I add 5 apples and 6 oranges, how many do you have? Well, I would have 5 apples and 6 oranges. Like I couldn't like just add them to say a level 11 apple oranges. That's not how units would work. And so physics is the same way here, that if we have an equation and I have a left side and a right side, well, what units I have on the left have to be the same units on the right. We can check that here with our position equals speed times time. Very basic equation. We're going to see it in our next lecture, maybe 2 lectures from now. Well, position is measured in meters. It's a length. And it equals speed times time. Well, that's a meter per second times a second. We see that on both sides of this equation, after we do some multiplication, we have the same unit on each side. But if I tell you that position is acceleration times time, well, that does not work out. So that this equation cannot be true. So dimensional analysis is really just a way of figuring out, does this make sense? Can this possibly be true? And if we have the same unit on either side, it can be. And if we have different units, then no, that equation is no good. All right, you might have asked why for position or why for length is it meters times seconds and mass kilograms. You might be more familiar with like feet and seconds you're probably pretty familiar with, or pounds for mass. Well, scientists use SI units, International System of Units, and we want to use those at all times in this course. Why? Everybody's measuring things the same way, and metric system is much easier to move things around with. We have this metric conversion table right here. So if I tell you what something is 200 centimeters, that should be pretty easy for you to convert to meters. You don't even have to set up like a unit conversion. We'll go into all of that. You just have to move things around on the table. But we will see a couple more examples with our conversions in a little bit. For now, we are going to use regular prefixed units or our regular base units when we're going to go into this dimensional analysis worksheet, which is going to be the subject of my next video. So, as always, if you have any questions, let me know, and that is it.